Here we have two physical changes. We have changes of phase only. Solid water turning into liquid water and steam turning into liquid water. For the first reaction, in order to make ice melt, the ice needs the addition of heat. So this is the energy that we have to put in to make this physical change happen. Notice the energy we're putting in is on the left side. The left-hand side of a reaction like this is called the reactant side. The reactants are our starting material, and they turn into the end material, which is called the products. So ice melting, we have to add heat to the reactant. The technical term for that is an endothermic reaction. When heat is a reactant, that's absorbing energy. This is an endothermic process. The bottom reaction, where we have steam condensing to liquid, if you added heat to steam, if we did the same thing that we wrote up here, adding heat to steam would never make it turn back into a liquid. The only way you can get steam to condense as a liquid is if you remove heat. So removing heat means we write heat on the product side. And when heat is on the product side, this reaction is releasing heat. That's an exothermic process. Chemical reactions, we're going to focus on the heat being either a reactant, endothermic, or a product, exothermic. Heat and temperature are not the same thing. When we're talking about heat, we're talking about transferring thermal energy. You put a hot object next to a cold object, heat will transfer naturally from the hot to the cold object. Temperature is a measurement, it's an amount of thermal energy. So next we have to talk about temperature scales and what units we use to record the temperature. Probably the most common unit we're going to use is Kelvin. Second most is degrees Celsius, and the least common in science is the one we're most familiar with, degrees Fahrenheit. The Kelvin scale is called the absolute temperature scale. Kelvin is equal to the temperature in degrees Celsius plus 273.15 Kelvin. So for example, the middle thermometer shows the Celsius scale. The Celsius scale was chosen based on the temperature where water freezes and where water boils. When water freezes, we call that 0 degrees Celsius. When water boils, that's 100 degrees. And then we can translate that into Kelvin. Water freezes at 273 Kelvin and it boils at 373 Kelvin. The coldest temperature that is possible is called absolute zero. And absolute zero happens to be at negative 273 degrees Celsius. If you add 273 to that, you get 0 Kelvin. So the nice thing about the Kelvin scale is you never have a negative temperature, where in degrees Celsius and in degrees Fahrenheit, you can have a positive or a negative temperature. Now we also have a conversion between degrees Celsius and degrees Fahrenheit. And the equation is the temperature in degrees Celsius is equal to the temperature in Fahrenheit minus 32 divided by 1.8. Now, in addition to measuring the temperature, we're also going to look at measuring changes in temperature. And in science, change is given by the letter delta, a triangle, so we're talking about delta T's, changes in temperature. Let's say we run a reaction where we start at 10 degrees Celsius, and then at the end of the reaction, we're at 30 degrees Celsius. Delta T is the difference between the two, and the rule is you always have to take the final temperature minus the initial temperature. So the final is 30, the initial is 10, delta T is a positive 20 degrees Celsius. Now for the same experiment, let's say that someone measured everything in Kelvin. So experiment number 1, we measure it in degrees Celsius. Experiment number 2, exactly the same experiment, but now we're using Kelvin. 10 degrees Celsius, to convert that to Kelvin, I just add 273.15 and I get 283.15 Kelvin as my starting point, and my end point is 303.15 Kelvin. So if I calculate final temperature minus the initial temperature, 303.15 minus 283.15 gives me a positive 20 for my difference in Kelvin. Notice you use a degree sign for Celsius, but you don't use a degree sign for Kelvin. So the delta T in degrees Celsius is exactly the same as the delta T in Kelvin. That's one nice thing about these scales. If you remember, the only difference between Celsius and Fahrenheit was we added a constant. We added 273.15. However, when we convert to degrees Fahrenheit, it's not that simple. We're not just adding a constant. We have to go through this formula. So if we ran the same experiment using degrees Fahrenheit, if I start with 10 degrees Celsius and use this formula to convert and solve for degrees Fahrenheit, I'll end up at 50 degrees Fahrenheit for my first temperature, and then my final temperature is 86 degrees Fahrenheit. And remember, it's exactly the same experiment, but now when I calculate final minus initial, I get a positive 36 degrees Fahrenheit. So delta T will be the same whether I use degrees Celsius or whether I use Kelvin. Those two will be the same. It's not the same if I'm using Fahrenheit. This is going to come into play later on. If you're working a problem, which we will, with delta T's, you have to be very careful which delta T you're using.